1a part I, state Hess's law in the reaction. The enthalpy change for a chemical reaction is independent of route taken. Part 2 is a Hess's law problem where you have to calculate the enthalpy of the reaction using delta HF data. Delta HF data means the enthalpy of formation of compounds data, which means you need the elements at the bottom of the cycle. The arrows move upwards towards the compounds, and the corresponding enthalpy changes are listed in the table. So the enthalpy change of formation of manganese oxide is minus 971 kilojoules per mole. There are 3 moles of carbon monoxide being formed, so it's 3 times 111. And on the other side, there are 3 carbon dioxides being formed, so 3 times minus 394. We must take into account these molar amounts. There's no value for manganese dioxide because, by definition, the enthalpy change of formation of an element is 0. So then, this is the direct route, this is the indirect route, so we have to switch the arrows around and switch the values around, and you can see I've written that in green on the left hand side. So the minus 971 becomes positive, minus 333 becomes positive 333, then add the 1304, minus 1182, that arrow is going in the correct direction, there's no need to flip that, and we get to plus 122 kilojoules per mole. You should write the elements here in full, in their standard states, as written there. Part 3, already talked about this. Why is the formation of manganese dioxide 0? By definition, the enthalpy of formation of an element is 0. These questions here is detailed knowledge of metals, metal extraction. So titanium 4 oxide means it's a plus 4 charge. So TiO2, remember, oxide is 2 minus. Chlorine, Cl2, and carbon extract titanium from its ore, leaving you with titanium chloride. TiCl4, that's a minus 1 ion, that's a plus 4 ion. 2 carbon monoxides is the other product. CO2 is also okay. You can have CO2 instead of carbon monoxide. The second stage of the extraction is with sodium. Again, learn the details from this in your notes. So titanium chloride, plus 4, remember, minus 1, plus 4 moles of sodium gives you titanium metal, and then 4 moles of sodium chloride, that's 1 plus, that's 1 minus, hence NaCl. Mg is also okay for that reaction as well, but it would be a bit different balancing. Check out your notes for that. Then we come to this equation. Balance the ions first. We can see that the ions have already been balanced with the number 2 in front, which means we need to have 4 ions on the left hand side. Next, look at chromiums. Chromiums is there, that's been balanced with the number in front. That's 8 there, so 8 in front of the sodium dichromate. Then we'll look at sodium. There are 16 sodium there. Go back and put the 8 in front, so that's 8NO2CO3 there. And now the oxygens. If you count these oxygens, you'll find it comes to 54. In these compounds, it comes to 40. So 7O2 means the extra 14. In this question, reduction with aluminium, what you've got to consider here is the formula of aluminium oxides. It's Al2O3. Aluminium is a 3 plus charge, oxide is a 2 minus charge. So write the formula of aluminium oxide. Chromium oxide you've been given would be 2Cr because it's a metal, not Cr2, 2Cr to balance, and then 2Al is the last part. So in 1D we asked the type of reaction that iron 3 oxide undergoes in the extraction. Well, if we're extracting a metal, we're going from an iron to a metal, so it's 3 plus to a 0 oxidation state, so it's a reduction. The gain of electrons, so reduction. The half equation, well, it's iron 3, so Fe3 plus is being changed to iron, so plus 3 electrons gives us the correct half equation. So it's plus 3 charge on the left hand side, 0 on the right hand side, so plus the 3 electrons there balances the sides. This next question doesn't really fit in particularly, but it's an important definition. The enthalpy change, the standard enthalpy change of combustion, the enthalpy change when 1 mole of a compound is completely burned in oxygen with all reactants and products in their standard state. The key terms have been underlined. This next question is about kinetics. You're asked to state the meaning of the term rate of reaction. Well, we've always got to consider it's the change in concentration of a substance over the change in time. And I've written the description there. Now if you look at point W, you can see that there's no further hydrogen being formed. Remember when you're measuring the rate, you take the gradient, the tangent, and you take the gradient of that tangent. Now that tangent here would be 0, so the rate is 0. And why has that happened? Well, the magnesium has all reacted. How do we know it's magnesium has all reacted? Well, it says that the magnesium has reacted with an excess of dilute hydrochloric acid, so it's therefore correct to say that all the magnesium has reacted and not the HCl. That is in excess. In this question we're asked, why does the rate of reaction double when the concentration of hydrochloric acid doubles? Well, there are twice as many hydrogen ions, or HCl, so therefore twice as many successful collisions in a given time. It's very important we say successful collisions, not just collisions. And get this phrase in as well with kinetics, in a given time. The next question is just state the meaning of the term activation energy. It's the minimum energy for reactions to start. The next question we're asked about the reaction profile diagram for an exothermic reaction. Well, in an exothermic reaction, the reactant's position is above the products. So this is the activation energy. That's the bonds being broken. This is the bonds being made. And not required, that there is the delta H. 1 mark for activation energy, 1 mark for the products. Next question is about barium reacting with water. So Ba2 plus, barium metal reacts with water, and the ion charge is Ba2 plus. For barium, hydroxide is 1 minus, hence Ba open bracket OH close bracket 2, and then hydrogen as the byproduct. Barium oxide is the product with the reaction of steam. Then we're asked for the simplest ionic equation. Ba2 plus ions plus sulfate ions go to BaSO4 solid. It's solid because it's a white precipitate. You do not need to show the state symbols. If you do, make sure you get them right. So some uses. There are several uses you need to be aware of for group 2. First thing is the barium sulfate used in baryonyl X-rays, and explanation: barium sulfate is insoluble. Remember, barium ions are really toxic, but barium sulfate is really insoluble, doesn't get into the bloodstream, so can't poison anybody. Then we're asked to think about trends. Solubility in water of the hydroxides. Remember, magnesium hydroxide is sparingly soluble. It forms a white precipitate, so as you go down the group, it increases in solubility, so barium hydroxide is soluble. The first ionization energy decreases down the group. Distance between the nucleus and the electrons is greatest in barium, so the attraction between the positive nucleus and negative electrons is weakest in barium, hence the electron is lost most readily. Then we have the atomic radius. Well, barium is the got the most shells, therefore has the largest atomic radius. Explain why calcium has a higher melting point than strontium. It's all about the strength of the metallic bonds. So the delocalized electrons in calcium are close to the positive ions, and therefore a stronger attraction between the positive cations, the negative delocalized electrons, means a stronger metallic bond. Question 3, we're thinking about compounds of iodine, and we're asked for the oxidation state of I2. Now, I2 is an element, therefore has oxidation number of 0. In hydrogen iodate, HiO3, read through this. H is 1 plus. There are 3 oxygens which are -2 each, so that's -6. -6 plus 1 for the hydrogen gives -5. Plus 5 minus 5 gives 0 for HiO3. So this is the reduction half equation, because you can see there's a gain in electrons. This is the oxidation half equation. You can see there's a loss of electron. So before you combine these two half equations together to get the ionic equation, you need to ensure that the electrons being gained is equal to the electrons being lost. You then combine the two together, so the electrons cancel. You can see here that this equation will make half an I2. Sorry, this is half I2 here. This 5 times 0.5 is 2.5 I2. That's where this working comes from. That simplifies to 3I2. The oxidizing agent is the chemical which gains electrons. The iodine is going from +5 oxidation state to 0 oxidation state. +5 there, 0 over there. So it is the oxidizing agent. The question carries on with sulfuric acid reacting with solid potassium iodide. A black solid is formed, and that is iodine. Deduce the half equation for the formation of sulfur from sulfuric acid. Make sure you write H2SO4 here. H2SO4 is changing to sulfur. Water is a byproduct. H pluses are required because it's in acidic conditions. It's a reduction half equation, so we need to have electrons. And it's in the order of water, hydrogen and electrons. That's the way we balance. So 4 waters, because there's 4 oxygens here. 6 H pluses here, because there's 2 there already. There's 8 on the right, so 6 H plus. Then balance the charges, 6 H plus, so 6 electrons to balance. Compound with a -2 unpleasant smell, rotten egg smell, is hydrogen sulfide H2S. Silver nitrate solution, or silver ions, as a test for the halide ions. Iodide, chloride, bromide. In this one it's iodide. Yellow precipitate is silver iodide, so Ag plus I minus goes to AgI. Concentrated ammonia does not dissolve the silver iodide, so no visible change, or precipitate does not dissolve. Why is silver nitrate acidified when testing for iodide ions? Well, nitric acid is the acid that it's acidified with. It reacts with carbonates and hydroxides. It reacts with them so they do not interfere with the test, because carbonate and hydroxide form brown precipitate with silver ions. Now we've got the displacement reaction. So this is chlorine reacting with iodide ions. Define the term reducing agent. Reducing agent loses electrons. It loses electrons to the oxidizing agent. So in this case, it is the iodide which is losing its electrons. It's going -1 to 0. Write a half equation for the conversion of chlorine into chloride. Chlorine, chloride, plus 2 electrons to balance. So it's 2 minus there, so it's 2 minus there. suggests why iodide ions are stronger reducing agents than chloride ions. Iodide is a larger ion, a larger ionic radius. It has a weaker attraction of its outer electron because it's a bigger ion, so its electrons are lost more readily. In question 4, we're asked to draw the Maxwell-Boltzmann for a higher temperature. This is the original temperature. A higher temperature, the average energy is greater, so the peak is shifted to the right. There are more particles with energy greater than activation energy in this region here. But because we've got more particles with greater energies here, it means the peak is a lower height here. Explain why an increase in temperature increases the rate of a chemical reaction. Well, there are many more molecules with energy greater than activation energy, therefore more successful collisions in a given time. You need to say successful collisions in a given time. Go back earlier on in this feedback, and I said that this change in concentration over the change in time. Again, we're talking about kinetics, so time is very important. The next bit is about the choice of catalyst, and use the data in the table to deduce which is the most effective catalyst for the decomposition. Well, this is the lowest activation energy for the ion. So as it's the lowest activation energy, it means that it's going to be the most effective catalyst. Without a catalyst, it's very high. You see 245. Platinum is least effective, the catalyst, then gold, and then iron is the most effective. And then finally, explain how a catalyst increases the rate of reaction. Catalysts provide an alternative route with a low activation energy for the reaction. The first mark is for saying they provide an alternative route. The second mark is that they provide a route with a low activation energy.